Right. Um, Today we are discussing about Kubernetes environment. Now I'm starting Kubernetes series. Before going that, what is Kubernetes? You should know about the Kubernetes. Kubernetes is a open source, widely used container orchestration software. That means containerization application. We can manage multiple application with large scale. What is the difference between Docker and Kubernetes? What is Docker? Docker is a platform to run and deploy and test the application quickly. That means containerization application is maintained by the Docker. And coming to the what is the difference between Kubernetes and Docker? This is one of the question. In Kubernetes environment, we can manage the containerization application by using uh, container runtime interface. Okay, the basic uh, advantage of Kubernetes um, is to scale up to scale down the applications. That means containers and automated scheduling. Suppose provides and it automatically provide launch the container when the resources required. That means suppose if one container in the advanced scheduling to launch the container on cluster node based on the resources requirements and other constraints and self-healing capacity. In self-healing capacity, suppose if one container is failed, the replacement was done automatically. Okay, this is about the major advantage. Self healing is a major difference between Docker Swarm and Kubernetes. Okay, coming to that, what is when it was Kubernetes was invented? Actually, it was invented in 2014 by it is using Golang software language. It was used in Google internal projects. After that, Google hand over to the Kubernetes software to the CNCF, Cloud Native Computing Foundation in 2014. Then after Kubernetes, the first version of Kubernetes was released in 2000, July 2015. Before 2015, they are built used in the Google projects. Okay. Now the latest version of Kubernetes is Kubernetes version 1.28, I think. Okay, coming to that. Um, Actually, Kubernetes is not replicate replacement for Docker, but Kubernetes can be considered as a replacement for a Docker spam. K8 is significantly more complex than spam and more work to deploy. This is the main difference between Docker and Kubernetes. And the few more advantages of Kubernetes is horizontal scaling and load balancing. That means scale up, scale down the application as per the requirement with a single command using user interface or automatically based on CPU usages. Okay, and service discovery and load balancing is one of the advantages. There is no need to worry about network communication between Kubernetes with automatically assign IP address to the container in a single DNS name for a set of containers. A storage orchestra with Kubernetes, you can mount the storage system of your choice. That means you can either OPT for local storage or public cloud. Okay, and automated rollouts and rollback. That means Kubernetes rollout changes to the application or its configuration while monitoring application health to ensure it does not kill any your instances at the same time. If something goes wrong with Kubernetes, they can roll back the change. That means if any changes required, they in the content, if any changes in the application, this is automatically roll back the if it affects the suppose if application is updated, there is an one bug is occurred. So if you want to roll back to the previous version, so Kubernetes automated the rollback changes of rollback changes. Okay, coming to that, this is about infra. What is this is traditional deployment, virtualization deployment. Traditional deployment means we are having a operating system, hardware, application physically. This is about the virtual deployment. This is about the container deployment. I will explain each and everything. Okay. Coming to the traditional deployment, there is a hardware. On top of hardware, there is an operating system. In olden days, the application size is also is used. It will take more time to up. So that's why if OSs fail, the application goes down automatically. So there is no alternative for that. So provide that coming to the virtualization deployment. In virtualization deployment, on top of hardware, there is an operating system or hypervisor. The on top of operating system, there is a hypervisor, and in on top of we can virtualize the operating system. The main disadvantage of traditional deployment um, the hardware resources utilization is not good. Suppose if you are running in Java application in traditional deployment, the hardware resources for memory space is suppose 1 TB. The application only running on 100 GB. The rest of 900 GB is free. We cannot use it for other applications. The entire hardware resources is allocated to the particular application. Okay. If you are add more applications into the same operating system, the machine goes down because of CPU utilization. To avoid that, there is a virtual deployment. Is there. In the virtual deployment, there is a hypervisor between the application and operating system. The hypervisor virtualize the operating system and allocate resources, hardware resources to the created applications in hypervisor. If the created operating system in hypervisor, the application is installed in virtual VM machine. So in this virtualization deployment, this is also challenging. There's only a single operating system is currently running on it. If it is failed, the entire system will goes down, right? Uh, and there is a hypervisor. That means the why when it was goes down means the utilization of CPU utilization, hardware resources utilization is exceeded. The machine goes down. Okay, to avoid that in virtualization, the hardware resources is equally divided to the created virtual machines in the hypervisor. Uh, so on top of virtual machine, we are installing application. It is very heavy weighted environment because it will take more time to uh, the application takes more time to uh, on. That means it will take more time to run. Okay. And coming to the latest containerization application. In containerization application, on top of operating system, there is a container environment. That means the container, that means the container environment, they are using Docker. Docker is a containerization platform to deploy, to develop, to run application quickly. Okay, there is no if the application goes down, it will not affect to the other application in the container runtime environment. And the containerization application is a very lightweight. It will take to few minutes to run. Coming to the running stage, okay, and the application um, uh, doesn't know about the operating system. In this container environment, if one application sometimes it takes more space based on load balancing. So in container runtime environment, the scaling, auto scaling, that means scale up, scale down the application. It is done automatically in container deployment. Okay, coming to that container environment, container deployment, there is a one concept is called Docker. This is a Docker. Docker is an open platform for developing, shipping, and running the application. It is a lightweight applications. That means few it is still coming compared to the traditional deployment. The application size is very less. Okay, containerization. And why we go for Kubernetes instead of Docker is Kubernetes having the self-healing. If container is failed, automatically scale create the container and to maintain um, high availability on the application in Kubernetes environment. So this is about the main concept in Kubernetes. Coming to the Kubernetes environment, there is an this is architecture of Kubernetes environment. I will explain what are the this is a there is in Kubernetes there is master and slave architecture. This is a master and this is slave. These two are slave. That means worker nodes. These are master node. In master node, there is a components called API server, etcd, controller D, scheduler, and kube proxy, kubelet also. But it is not in mentioned here. And I will explain each and everything. Okay. Coming to the worker node, the only kubelet, contain runtime Docker. It contain runtime. I will explain later. Network proxy for communication between the um, worker nodes. Okay, coming to that pod. A pod means what is a container environment? It will maintain more than one application, one containers. Okay, each pod having the individual IP for communication to each other and a kubelet. I will explain. Coming to that, this is what is API server. API server is main gateway developers to access the Kubernetes through API server. This is main gateway to access the Kubernetes environment and controllers. um, API schedulers watches the pods and assign the to run the specific roles. That means scheduler schedule the pods. If one pod having the containers, so one pod was failed to the API server, the request is coming to the API server, and one pod was created automatically. Then to scale the application. Okay. Then what are the master component? The master component. What are the components in the master server is API server, kubelet, kubeproxy, controller, scheduler, and we're coming to the worker node, kubelet. I will explain each and everything. Um, Coming to the master server, there's a kubeproxy and kubelet also. Kubelet is a node agent. It is maintain the health checks of slave cluster health checks. A node health checks is maintained by the kubelet. And group proxy coming to it is a network proxy that runs on node in a Kubernetes cluster. It is responsible for maintaining the network communication between services and pods. That means with the help of kube proxy, you can maintain the network communication between the pods. Okay, pods having the container having the application. Okay, kubelet, and there is one kubectl command. The kubectl command is command line tool for communication with the Kubernetes cluster. kubectl is a command to contact, that means to provide communication between the Kubernetes cluster and this command interact with the API server. The developer by using kubectl to communicate with the Kubernetes cluster. Okay. Coming to that, scheduler is going to schedule the pods into the nodes. That means somehow in worker node, suppose one pod was failed, the request is going to the API server and create another pod replica set. That means create another pod to provide highly availability to the application. Okay. And coming to the control run manager. This is the control run manager. The control manager does not directly modify the resources in the Kubernetes cluster. Does not modify the resources in the Kubernetes cluster. Instead, it maintains the multiple controllers responsible for specific activities. It performs cluster level functions. That means node controller, endpoint controller, replica set control, deploy controller, replication controller, daemon set controller. These are all controls maintained by the controller and manager. And node controller. That means it is responsible for node. Okay, replication control means it means number of pods. The controller maintain the node controller. Replication control means it is maintain the required pods. Replica set control means number of replications of pods running at a time, at all time. That means number of replication of pods. That means each pod having the same information. And deployment controller declarative updates for pods and replacement. Okay, a daemon set control for it is used for background process, used for deploying background services across clusters, providing. Um, okay, this is about the node control run manage. Okay, and coming to that container runtime interface. This is a container runtime interface is in worker node only. Okay, the entire worker nodes maintained by the master node. In worker node, we are for containerization we are using container runtime environments called oh, I forgot it. Etcd directory. Forgot to explain about etcd direct etcd in master node. Etcd master node, it stores the configuration. It can be used by the each of the node. That means if you want to install one container, if you want to create one container worker node, the creating process is stored in the etc directory. That means, and coming to the kube proxy, we already told that kube proxy is provide the communication between the pods and services also. Okay, these are the objects in master and worker node, and in worker node container runtime I have forgot it. And coming to the container runtime software, the container runtime is a software that is responsible for running containers. Okay, KTS containers. Its short form is KTS. KTS supports several runtimes. They control container D. These are the container runtime environments. Runtime interface, container D, Docker engine, CRI-O, Rocket. These are container runtime interface. The main is Docker deprecating the Kubernetes. Is Kubernetes deprecating the Docker? No, because Docker is does not maintain the container runtime interface. That does not develop the container runtime interface. So that's why Docker is does not directly supports the Kubernetes does not directly supports the Docker. But why we are using Docker? That means Docker is every time maintain the containerization application. So Kubernetes developed Docker shim of it is a container runtime interface, and using the with the help of Docker shim, uh, Kubernetes using Docker Docker image application, Dockerized containerized applications in a Docker environment. Okay, and I already explained about the Kubernetes features and storage orchestration. Okay, and okay, coming to that, uh, with the help of container D, Kubernetes can maintain the containers. There is no in long run there is no need of middleman role by the Docker because Kubernetes directly communicate container, so there is no need of Docker no longer needed in the middleman role. Docker is still strong tool for developing the containerized application. So because of the containerization application, okay, and Kubernetes will also continue to be able to pull the images from Docker registry. There is no alternative till now. And coming to the Docker resources are images, containers, networks, volumes, and services. Coming to this, there is a Kubernetes resources are parts, deployment, replica set, replication, state demand set, persistent volume, service. These are the Kubernetes resources, services, namespace, configuration map, job. How to set up Kubernetes cluster? There is a Kubernetes cluster as three type of Kubernetes clusters. Okay, single node Kubernetes cluster. That means single node can be act as a master as well as worker. And self-managed Kubernetes cluster. Then coming to self-managed, these responsibilities only developed who are developed the self-managed Kubernetes cluster by me. And managed Kubernetes clusters are there is a cloud environments are managed by Azure, EKS, GKS, AKS, GKE, IKE, OKE. TVKS means Elastic Kubernetes Services. AKS means Azure Kubernetes Services. GKE is Google Kubernetes Environment Engine. Sorry. IKE means IBM Kubernetes Engine. These are our managed clusters. Coming to the self-managed clusters, we can create, manage, install on the top of the server. If something wrong on worker node, whatever the parts in the current node will be recreated and rescheduled to the new node. The above task will not do by using self-managed Kubernetes cluster. We only handle the failures. By using Kubedium, Kubespray, we can manage above the tasks. Okay, what is Kubedium? Kubedium, we can bootstrap the Kubernetes cluster. Kubespray, that means Ansible way. That means that means by using playbooks, we can configure the Kubernetes cluster. And coming to the port number, the API server of Kubernetes, they are using a different port number. The API server 6443 is run, and API kubelet, its IP address is 10250. And coming to the scheduler, its port number is 10259. The port number of kube controller 10257. Coming to the etcd, the port number is 2379 to 2380. There is a node port service. The port number is 30,000 to 32,769. Sorry, 767. These are our port numbers of master node in Kubernetes cluster. And this is about cube mini is mini cube is a concept to create the single node cluster mini by using mini cube. Okay, and there is a concept called COPS. It is a software to create and manage production grade Kubernetes cluster. For production grade Kubernetes cluster, there is a concept called COPS. There is a COPS. supports AWS and GCP are efficiently supported COPS. Other cloud service doesn't support. They'll the to maintain that Kubernetes cluster by using command kubadm to interact with the Kubernetes cluster kubectl. This is about basic structure of Kubernetes environment. Now I'm winding up my session. Thank you. In the next video, I will explain the Kubernetes setup, creating Kubernetes cluster, setuping a Kubernetes cluster. Right.